Start with ionic compounds, which are made out of ions. And the simplest ions are monoatomic ions. So this is when one atom forms one ion. Okay, so a single atom forms a single ion, and we can predict the charge value if it's going to be a positive or negative ion, and if it's going to be +1, +2, or +3, or -1, -2, or -3. That's called the charge value. So the way you predict the charge, whether it's plus or minus, and the value, such as +1, +2, +3, and so on, is you can predict the charge and charge value for the A series elements by using the family number, the group number that's at the top of the column, the vertical column, and this is for families 1A, 2A, 3A. Those are the A series, okay? And then you jump over, you have 3A, 4A, 5A, 6A, 7A, 8A, okay? So metals, that's on the left side of the periodic table, these form positive ions. These are called cations. If you're a cat person, you have positive thoughts about that, positive ion. So family 1A, family 2A, and family 3A are all metals on the left side of that stair-step line. So these all are atoms or elements in those columns will form positive plus charge ions, and everything in family 1A forms +1 ions. Okay, so when you look at that first column all the way over on the left, family 1A, one example would be sodium is in that column. And so sodium is in family 1A, so sodium forms a +1 ion. Okay, there's different ways to write this. You could write +1, 1 plus, or just plus. Okay, and so this actually is the most common is Na plus. This is the second most common, Na1 plus, and that's the third most common is +1. Family, so I should write 1 plus or +1. Okay, family 2A elements. So this is that entire column of elements forms +2 or 2 plus. Okay, that's the same thing. So if you take any element in that column, like calcium, calcium forms a +2, or you could write it 2 plus. Okay, and this one is considered the more formal way of writing calcium 2 plus. So this is family 3A, which is jumping over to the right. That family 3A forms 3 plus 3 or 3 plus. And so aluminum is the only is the metal at the top of family 3A. So aluminum, the element, forms aluminum +3 or this aluminum 3 plus. Okay, and so this is what we're saying here is that you have elements in the periodic table. Oops, go back. You have elements in the periodic table that are present in nature, and they are around. You can find aluminum, like aluminum foil, but it's more stable, in fact, as this aluminum ion. Okay, and calcium, family 2A, these are the alkaline earth metals, and we talked about these as a family property, that these are very reactive, or these are reactive metals. So what that means in saying that they're reactive is that they're actually not around in this form. They're more commonly reacted and formed this ion. So this is the more common calcium ions you'll find. You actually won't find a lot of calcium around just as calcium atoms, but you'll find calcium ions around. And that's definitely true about family 1A. So family 1A are the alkali metals. And these were very reactive metals. And these are actually not really, you're not actually going to find sodium easily in nature because it's reacted and it is formed this ion 1 plus or +1. This ion is the most common version of sodium that's around. And when you're talking about sodium chloride, table salt, it's not this sodium element, it's sodium the ion that is more present in nature. And that's because all of those in family 1A, including sodium, are very reactive, and they've already reacted and turned into ions. So nonmetals are on the right side of the periodic table, so the right side or above the stair-step line. And nonmetals tend to form negative ions, which are called anions. So that has a negative charge, or anions. Another thing you might be familiar with are the electrodes on a battery are called a cathode, which is a positive charge, like cations, and an anode, which is a negative charge, like anions. We'll get back to batteries in Chapter 7. But these are anions, are negative charge. So nonmetals on the periodic table, that's to the right and above the stair-step line. These are family 5A, 6A, and 7A. So family 8A, remember, are noble gases, and those tend to not react, which means they tend to not form any ions. So families 5A, 6A, and 7A, you can predict the ion charge. These are all going to be negative. Okay, and from family 5A, these form -3 or 3- ions. Family 6A forms -2 or 2- ions, and family 7A forms -1 or 1- ions, or just negative. So an example in family 5A, in that whole column, let's take nitrogen is N. And so nitrogen tends to form the -3 or the 3- ion. Okay, and that would be the formal process for writing ions is usually to write the number and then the negative. 6A is the family that contains oxygen. And so oxygen, when it forms an ion, forms a -2 or a 2- ion. Now this is, it's still true that nitrogen and oxygen, when they are in nature, are diatomic elements. They're molecular elements. And that's N2 and O2. But here's why they are molecular. It's because nitrogen and oxygen would prefer to bond to another atom rather than become these ions. But it does happen that nitrogen forms this ion and oxygen forms this ion. Okay, so these are ions that can form for nitrogen and oxygen when they are not as the molecules N2 and O2. In family 7A, so family 7A, these are the halogens, that's the family name. And so we have chlorine in that family. So chlorine forms the -1 or 1-, or just Cl-. You'll see me write it like this, and this is the 1-. They're all equivalent. And these halogens are very reactive nonmetals. And so it's also true that halogens, these Cl2 is a molecular element, is another molecular element. And so in nature, when chlorine is found in nature, it's typically found as Cl2. But when broken apart, it can be present in the ion form Cl-. And this is also to say, in the same way, that when you have chlorine around in nature, it's going to be Cl2, but you're not actually going to have chlorine atoms. Okay? Chlorine atoms are not as common because halogens are very reactive and they've already turned into the ion form. So Cl- or Cl1- or Cl-1. So they've already reacted in formed ions for most of the halogens.